G'day everyone, sorry for the interruption, we'll be back to the video in a second. Just wanted to say, if you're watching this because you're working from home or perhaps you're on lockdown at home and stuck there and you're looking for tech content, hopefully you enjoy this and hopefully you use this time to improve upon your own tech skills. But most importantly, stay safe, stay healthy, and be mindful and respectful of the needs of others in this time. Anyway, on to the video. Well, welcome everyone. It is office hours time again, as always. Thank you for joining me. Obviously, it's been an interesting month interesting few weeks since last we spoke. There's been a few things happening in the world. We'll cover them to some degree tonight and see how we go. But yeah, obviously, thank you very much for giving up your time. If this is your first occurrence of working from home, well, there you go. This is a brand new adventure for you. I work from home all the time, but yeah, hopefully you're going to enjoy the session that we have on. So let me start a fresh share and we'll see how we go. As I always do when I start office hours, we say getting in touch is easy, especially so in these days now where everything I think we do together will be pretty much online as opposed to face-to-face. I do like talking tech, so my Twitter handle is there. Don't be surprised if the Oracle world has gone a bit dark on Twitter for a little while. We're just making sure that no one misinterprets our social media posting as in some way sort of being ignorant of the fact of the challenges the world is facing at the moment. So we're a bit quiet on Twitter at the moment, just in order to make sure that we're respectful to our own community. But you can get in touch with me on Twitter and, as always, via the other links, Facebook, Instagram, blog, etc., all through that Linktree link. For those who are new to office hours, maybe this is the first time you're joining us online because you normally have an office to work in. Do not adjust your set. All the slide content always appears sort of down toward the left. That's because when we turn this onto a video later, it will become my face in the top right, content in the bottom right, in the bottom left, and hopefully it all balances quite nicely. A few bits and pieces, as I always like to do before we get stuck into the actual content. First, as I said, a public service announcement. Obviously, the coronavirus has been dominating the news, COVID-19, depending on how you'd like to call it. I've had some interesting challenges. I normally travel a lot, and obviously that's come to a rapid conclusion. We'll talk about that in a second. But I just wanted to say thank you for those people that reached out to me on social media platforms, basically making sure I was okay, making sure I wasn't stuck in various countries. As it stands at the moment, I fall under the banner of an Australian rule, which is when you arrive from international or from overseas ports, you spend 14 days in isolation. As I said, I work from home, so it's not a big deal. My partner Genevieve thankfully went out and bought me some food and threw it over the back fence like a United Nations aid drop. The only downer for me is I don't get to play with my kids for the next couple of weeks, which is a bit sad, but hopefully this content will make up for it. To give you an example of what I faced recently, that is Gate A at Dubai Airport last weekend. And rest assured, if you've ever been at Dubai Airport or even heard of Dubai Airport, rest assured it doesn't look like that very often. If you look carefully, you might see one other person. He walked into shot, but other than that, that was the only other person in the entire gate I saw while I was in Gate A at Dubai Airport. It's one of the biggest airports in the world, and as you can see, it looks a little bit different there. So I thought I'd cover off what we've done. We normally talk about what we've done in the last month, and there was OUG Ireland, and of course, didn't go to that. That got cancelled. There was a Qualogy public event in March, and that got cancelled, but a big shout out to Patrick Burrell. He managed to, at fairly short notice, organise a company-only event. So I went and visited Qualogy in their office, lovely people there, and we had an evening event. They fed me, we had drinks, and we literally did 4 solid hours of content. So just over 1,000 slides. So it was a big night there for them, and I thoroughly enjoyed it. Thanks again to Patrick. And I'll come back to that event shortly to offer you something else. And of course, then there was Apex World, and it's normally held in a boat. It's a fantastic event, but one would imagine anyone that's going near a boat at the moment generally is probably not of sound mind, because cruise lines and the like generally are getting some pretty bad press. So that was cancelled as well. The Romanian user group were the poor victims of this. They were still going to run their event, but unfortunately, because after these other events have been cancelled, been stuck in Europe for the best part of 2 weeks, or would have been stuck in Europe for the best part of 2 weeks, unfortunately, I had to make my way home to sneak into Australia in time. But once again, we ran the event online for them. It wasn't perfect because I didn't pack a webcam on that trip because I hadn't planned on doing anything online. But we made best with the equipment we had. Did I keep it here? I actually had to go buy lights from a local store in Holland because, as you know, hotel rooms are normally terribly lit. But I bought some lights to at least light myself a bit better. And yeah, we actually ran an online event. But the actual official event was cancelled, the face-to-face. That brings me to something I just want to talk about. Obviously, user groups or companies, you're in somewhat uncharted waters at the moment. We've got almost no one working from their offices. You've seen heaps of conferences and stuff being cancelled. But as we do with office hours, we run these events through Zoom, and we obviously have a corporate license which lets us use Zoom for large-scale events. Some of the office hour sessions on Apex and machine learning run well into the hundreds. So if we can help you, if you're looking for some content just for your company, or if you're looking for some content for your user group, and obviously it's a problem because you can't bring people together physically, please reach out to us. We'd love to try and help you out. We can run some events for you, like this quality one, which was a face-to-face, but like the Romanian one, the same. If you've got people that want to come together and talk tech, yeah, organize it, and we'll put an Oracle host on there, and we'll help you out. We'd love to use our Zoom facilities to help you keep your communities growing stronger and stronger. So what's in this session? Let me check my slide. What have we got? We're going to talk about BIGFILES, ROWIDs, data patch, instant caging, faster installation, and cloning databases. Hopefully in the next 53 minutes, we'll do our best. Some of these are a little bit fast, so we'll do our best. I'm cognizant of the fact that I think there's another office hour starting in an hour's time on the same day. I think it might be Chris's SQL one. So yeah, so I'll definitely do my best to finish on time. So let's talk about BIGFILE first. In fact, we're not going to talk about BIGFILE first. This is the question. What is a BIGFILE? I understand from the name that it's obviously for bigger files, but why not just have more files? I don't understand. So we're going to come back to BIGFILES because to set the scene for BIGFILES, I want to talk about ROWIDs first. So let's talk about this one, and we'll return to BIGFILES. ROWID. Most people know what a ROWID is, but here is a question that came into me. I see blog posts about the ROWID. Sometimes it's just a random string. Other times it seems to be a sequence of hex numbers. Are they the same thing? Can you please explain? And for those people who are dinosaurs on the call like myself, I won't throw any names there for familiar suspects I see on the call, but the ROWID is one of those things that has, it's part and parcel of our understanding of the database structures, but it actually has undergone some changes over time. So let's talk about the ROWID and why it might be a series of random strings, or it could be some hex numbers. Now to do that, we're going to take a little trip down memory lane. Once again, thanks to a friend of mine, Patrick, who supplied this. What do I mean by a trip down memory lane? Take a look at this gem. This is a virtual machine running under Oracle VirtualBox. And if you're young on the call, you may not recognize what that operating system looks like. That is Windows NT version 3, one of Microsoft's first server platforms. Now, why VM with a Windows server of that age? This is 20 plus years old, because you can see there in the middle, there's an Oracle installation on this. In fact, before we jump into ROWIDs, I thought I'd show you some of the cool things at how Oracle used to be back in the day. So this is Oracle 7. And when you used to run Oracle 7, you would get things like this, which is, it's going to continue without a repository. This is the predecessor to things like Enterprise Manager. So you can check what sessions you have, in-doubt transactions. That was about it. You can check your init.aura parameters, and there we go. That's Instance Manager. You could have this one, which is Schema Manager, which looks a bit like the object browser in SQL Developer. You have tables, you could expand. Yeah, there's the Scott schema, etc. It's all running under Windows. And we walk along. This is the SQL worksheet. This was going to be the successor to SQL Plus, but it never really took off. But you can run queries in there, for example. Can't remember how you actually run something. Maybe it's down here. There we go. There we go. And then you get the output on top as opposed to below. Once again, a forerunner to SQL Developer. Let's not save those changes. What else did we have? We had the storage manager, so you could manage your table spaces and the like. And you had this one, which is the backup manager, so you could actually take backups of your table spaces and the like. This is security manager, which I think is, yeah, if you want to create users and change their passwords, etc. It's memories of a beautiful time. So that's the administrator toolbar. But to talk about row IDs, I'll fire up SQL Plus, and as you can see, SQL Plus hasn't changed. It's looked the same. The features in SQL Plus have changed over the years, but the look is pretty much the same. And you can see that we're on Oracle 7.732. I hope anyone on the call is not running Oracle 7 in production, because it's just a little tiny bit out of support. So yeah, so if you're running Oracle 7.3, time to upgrade. But let's have a look at the row ID from the employee table. This is how row IDs used to look. And in Oracle 7, they had this common structure. You can see it's sort of 3 pairs of strings. You don't see that in a modern version of the database. You see something quite different. This is why I was very keen to show you this, so I wasn't lying to you, that this is actually how row IDs used to look. Let's explore that a little bit further. We'll come back to our VM. To discuss how our row ID is formatted, we need to understand how the database is structured. And anything that consumes space in the database is called a segment. Those segments are built up of extents, chunks of data, contiguous data on disk that actually get allocated as the segment grows. You create a table, it occupies no space. You start putting rows in, you get the first extent. When that extent is full, you get the next extent, etc. Each extent is made up of database blocks. This I actually got from the Oracle 7 manual, this little screenshot, just to show how things have changed. And in those days, the default block size that a lot of people used was a 2K block size. Most of us have known now that 8K is pretty much the way to go, but the concept is the same. Segments consist of extents, which consist of blocks. Now, those segments and those extents exist in files. Everything that sits on a server ultimately sits in some sort of file. It may be a physical file on disk like you see here, but it could be something in ASM, could be a raw device, but ultimately it's some big, large allocation of space on disks somewhere. As tables grow, they allocate extents, and those extents get allocated in one or more files. So to know where a particular block or row in a table is in the database, you obviously need to know the file it's in. You then need to know what extent it's in. And really, the extent is a logical concept because an extent sits in a position in a file. So you really just need to know what offset from the start of the file that's in. So the block number. And then inside that block will be an 8K block or a 2K block, and then we'll have the rows inside that block. So we need the file number to decide what file it is. We need to know the block offset. How far into the file do I go in blocks? It could be in bytes, but blocks is useful for us because it's the unit of size in the Oracle database. And then inside that block, we need to know the row number. There might be 10 rows in a block. We might be interested in the 9th row. And that's effectively what we get when we look at the row ID way back in Oracle 7. We have 3 sets of numbers, which are indeed the file number, the block number, and the row number. In fact, we can actually, even without having this annotated, we can get some idea of what this probably is here. Given that the Oracle, the Scott.emp table is so small, we can see that it's probably the third, let me start again. The third set of digits there is probably the file. It's C, or maybe the 12th file. The first set of digits is probably the block number. That would be the largest number we would have because we have to offset a large amount into a file. And the middle digit is most probably the row number because we have the 0th row in a block, the 1st row, the 2nd row, etc. And that's what we have. File number, block number, and then the row number. They are 3 attributes that make up a row ID. If you look at a row ID as it comes out on the screen like we saw in our VM, and you'll see this occasionally on blog posts as well, if we actually add up the bytes there, you can see we've got 8 bytes, then 4 bytes, then 4 bytes. That would seem to suggest that the row ID is 16 bytes of information. This is not true. Or you might be thinking, well, they're hex strings. So normally with a hex, you have pairs of characters to identify a byte. So maybe you're thinking it's 4 bytes for the block number, 2 bytes for the row number, 2 bytes for the file number. Even that's actually not the case. It actually is 6 bytes. And we can actually prove that. If I go back to our old VM, our beautiful Oracle 7, let's do a dump function. Oh, a whole lot again. And we can see if we actually dump out the row ID from a table, the length is actually 6 bytes, even though on screen it appears to be larger. So 6 bytes is what we need for a row ID. And the way it's been structured to occupy those 6 bytes, the file is allowed to be up to 10 bits. 10 bits means you can have 2 to the power of 10, that's 1024. The block is 22 bits long, which is 4 million, 2 to the power of 22, and the row is 16 bits. So based on that, the way the Oracle database works back in Oracle 7 is to identify a row, it must be in one of 1024 files. In that file, it could be up to between 1 and 4 million blocks across in the offset. And then we have 16 bits per row. So even then, back in those days, Oracle was allowing potentially 65,000 rows in a block, which is impressive. Not that we could actually ever achieve that with the block sizes we have. Given that we have 1024 files, each one could be 4 million blocks with, let's assume an 8K block size. If we throw that into a simple calculation, we can see that the theoretical maximum for an Oracle database back in Oracle 7 was 32 terabytes. Now, that wasn't a big deal because back in Oracle 7 days, we ran Oracle 7 on servers like this. This is actually a Sun Enterprise 450. I worked with these when I first started working with Oracle 7. In those days, this was a fairly hefty box. It was a powerful box. The chassis there, you could hold 20 disks, 20 SCSI disks in those days, up to 9 gigabytes each. So we didn't talk in terms of terabytes in those days. 200 gigabytes, for example, was a big database way back in the Oracle 7 days. You know, you would sort of hear of certain organizations, approaching the mythical terabyte mark. So having a ceiling of 32 terabytes was plenty back in Oracle 7. In Oracle 8, which came along at the end of the last millennium, sort of the late 90s, we had a problem because the world was starting to get bigger. We were starting to accumulate more data. And so we wanted the database to actually scale to beyond 32 terabytes. That introduces 2 problems. One is, just because people are upgrading from 7 to 8 doesn't mean, as Oracle, we really had the right to say, look, we want to change the way we address information on disk because 32 terabytes isn't enough. Is it okay if you unload and reload your entire database? To do so, one of the prides that we take in Oracle is you've never ever had to unload and reload your database to do an upgrade. It's always just a dictionary upgrade. So we need to be able to map to larger than 32 terabytes, but not change the row IDs we currently have. We don't want to have to consume more than 6 bytes for a row ID. The second problem is, as we saw before, when you query the row ID, it comes out looking like an 18-character string. In fact, if I go back to my VM, scroll off a bit, you can see that's 18 characters across the screen, including the full stops. Once again, if you've got applications that are currently querying that value out and storing it, we don't want to then, if we're making a larger row ID in some way, to say, oh, by the way, go change all your applications now because that string we returned is no longer 18 bytes, it's going to be 24 or 32 or something. So we had to tackle those 2 challenges. How do we keep the internal representation at 6 bytes, but still be able to address more? How do we keep the external representation at 18 bytes or less, such that people don't have to rewrite their apps? So let's tackle this one first, the 6-byte problem. We have currently 10 bits for the file. the original row ID that looks like this. Ideally, we just like to make, perhaps that bigger. What we could do is, rather than have it being the file for the entire database, which caps us at 1024 files across the board, the first architectural change we made was we will keep that 10 bits for files, but we will make it relative to the table space. So now, rather than having 1024 files for the database, you can have 1024 files for every single table space. And the cool thing with that is the existing row IDs we would have in Oracle 7 when we upgraded could be left untouched, and we could just make an assumption about them. If we didn't see any table space information, then we know that it's a one-for-one mapping from the old style. So the first 1024 data files in your database will be untouched, and then as you add more than that, we'll have them relative to the table space. In that way, we don't have to change any existing data, but we've introduced this new facility which says files are now relative to table spaces as opposed to the entire database. That's very, very cool, except along with Oracle 8.0 came a new piece of technology. One is partitioning, and the other is transportable tablespace. Now, transportable tablespace was the ability to let you unplug a tablespace from one database and plug it into another. If we were now going to start embedding the tablespace information, so a numeric ID that represented the tablespace, into the row ID for new rows as they come into the database, then we've got a bit of a problem, because when we plug that tablespace in somewhere else, we might have some conflicts. So rather than doing the tablespace in the row ID, we actually changed it. We said, let's store the object number for that particular object in the row ID. The object number can be used to map to the dictionary to tell me what the tablespace is, and therefore I can pick up that information. And now I don't have to have this physical thing called the tablespace ID stored in the row ID. I can just have the object ID. And this is what we did for Oracle 8. The Oracle 8 row ID can be larger than 6 bytes, but the joy is all the existing row IDs stay at 6 bytes and are implicit. They map to what they were before. We don't have to change anything. When you create new row IDs in Oracle, we have this. We actually have 4 pieces of information in there now. We have the file, block, and row as before, the file being relative to the table space. And the way we identify that table space is to store the object ID in the row ID as well. I'm making a bit of a simplification here. There is a discussion that we could have later on another office hours about object ID and data object ID. They're 2 different attributes. But for the time being, let's just keep it nice and simple. We now have 4 attributes stored on the row ID. File, block, and row as before, and the object ID. That brings us to now 10 bytes. 10 bytes for new row IDs as they get created in the database. The remaining row IDs that were existing there stay at 6 bytes and never need to be changed. That gets us onto the second problem. Originally, we were displaying 3 pieces of information, the file, the row, and the block, in 18 bytes. That's sort of 3 sets of digits we store in the string. When we bring it out to the outside world, it looks like this. Now, if I was just to keep that model and just have that same sequence of hex digits on a new row ID, which consists of 4 attributes, it would look something like that. Now, that's obviously bigger than 18 bytes. It's going to cause grief for customers. So the question is, how do we show 4 pieces of information in the space that we used to show 3? The first thing we did, we ditched the dots. They're just chewing up 3 precious bytes that we'd rather have, so we ditched the dots. And the second thing is we changed the base. If you look at the examples we currently have, all the row IDs come back as hex. Now, how does hex work? If you want to show, for example, say 24 bits or 3 bytes of information in hex, you need 6 characters, 2 characters per byte. I chose 24 because if we change the base to say base 64, for 24 bits, you only need 4 characters, not 6 characters. Now, what's base 64? We need the uppercase letters, that's 26, the lowercase letters, that's 52, the digits 0 to 9, that gives me 62. How do I get the 2 remaining bits for base 64 representation? We throw a slash and a plus in there. And so there we have our 64 distinct characters to make up base 64 notation. So we can take our row ID that looked like this historically, convert that entirely to base 64, and it now looks something like that. Even if it has the object ID information in it, we can now compress it down to an existing 18 characters of display information for a 10-byte row ID, because we're now using base 64 technology. So even those longer row IDs like that will still come out as a shrunken 18-byte string. What does this mean? This is very cool, because now we have 6-byte row IDs left untouched, no issues with upgrade. New row IDs become 10 bytes, giving us greater addressability. We have 1,024 data files per tablespace. You're allowed to have 65,000 tablespaces in an Oracle database. That gives us a ceiling of 2,048 petabytes in an Oracle database. So it's, what's that? That's is it exabytes after that? Hence the term exadata. But there you go. Once again, we had this transformational jump in the scale of what you can store in an Oracle database from Oracle 8 onwards. And that's why row IDs look sometimes like hex strings and sometimes like base 64 strings. It depends on how you want to display them and how they're stored, and historically how we used to store them. So hopefully you found that interesting. One thing I will say before I move on to BIGFILE is, what am I going to say? Right. One thing I will say is, if you want to dig into the components of a row ID, there is a database package supplied called dbms_row ID. So if you are presented with a string old or new, you can convert between them, and you can also dig out things like the object number, the file number, the block number, if you ever wanted to see whereabouts physically on disk a particular row or particular block was stored. Okay. Man, did that take too much time. That's not good. So now we're armed with information about row IDs. Now we can tackle the issue of BIGFILEs. So here's the question: what is a big file? I understand that they're obviously just bigger files. That's what the name suggests, but why? Why not just have more files in your database? Before Oracle 8.0, with the historical row ID we used to have, the maximum data files in a database is 1,024. With the new row ID that came in Oracle 8.0, we now have maximum data files per tablespace of 1,024, 65,000 tablespaces per database. That gives us incredible scale, but it also gives us potentially 67 million data files. Now, if you've ever had a folder on your Windows machine or a USB stick or anything like that, and you've done delete 67 million files, rest assured, it takes a while. Managing that many files is a big drama. In fact, one of the motivations for storing information in a database is because file systems generally weren't designed to scale to millions or billions of files. Operating systems tend to struggle when you get to that many data files. But back in the Oracle 8 days, that's pretty much the only option we had, because a lot of the databases ran on file systems which simply didn't have capacity to have single files larger than a certain amount. You go back to those times when you had things like NTFS or FAT32 and FAT and stuff like that for Windows. A lot of files were capped at 4 gig or 32 gig or those binary powers. Therefore, if you wanted to have a large database, you had to have lots of files. So we had our 10 bits for files, our blocks there. So we had a ceiling inside Oracle as well of 4 million blocks. So if even no matter how big a file could be on the operating system, 4 million blocks times 8 kilobytes, typical block size, means you're capped at 32 gigs. That is the biggest file you could ever address inside an Oracle database, because we only allocate 22 bits for the block of reference. So 8K block size means the largest file you can have is 32 gig in an Oracle database. That's why when you create a brand new database, even in recent versions, you'll notice that the files generally auto extend out to 32 gigabytes on an 8K block size, because that's the highest number of blocks that we can reference with your standard row ID format. Over the years, of course, operating systems have caught up. They now support much, much larger files than 32 gigabytes, or Oracle introduced their own effectively file management system. Once we started getting the things like ASM, we didn't need to rely on the operating system in terms of what it could provide in terms of files. We could control that stack in the storage ourselves. But even with those advancements, the conventional ROWID leaves us stuck at 22 bits for a block offset, which means 4 million blocks, which means we're capped at 32 gigabytes. Maybe there's a way around it. We introduced the concept of files per tablespace back in Oracle 8 because we wanted to be able to grow the database larger. But then the operating systems caught up. They said we could have bigger files. ASM came along. You could actually have files that aren't managed by the operating system. So maybe having multiple files per tablespace is something we could do away with. Maybe we could just have massive files for tablespaces. Because if we do that, if we ditch the file number inside these ROWIDs, then we could allocate those 10 bits to the block number as well. Rather than having 22 bits for a block reference, we could suck those 10 bits in we used to use for files into being a block offset as well. If we can't have a file offset per tablespace, we're now limited to 1 file per tablespace because we've thrown away the file reference. But what it does do is give us 32 bits worth of block offset. What that means now is, yes, we have 1 file per tablespace, but that file can be up to 32 terabytes now in size with an 8K block size, as opposed to 32 gig in the old days. So that's what a big file tablespace is. You sacrifice the multiple files such that we can pack more of those bits in a ROWID into the block offset as opposed to the file number. All we've done is effectively refactor those file bits into block bits. 32 terabyte files, still 65,000 tablespaces per database, still incredible scale in terms of what you've got there. But now you have less files. That could be easier management for you as a DBA, but also, most importantly, easier management for the operating system to manage all those files. Operating systems generally don't do well with millions and millions of files. One of the things that people panic about when they hear about big files is, well, I hear a lot of things about backup and recovery or various parallel operations that require on the file by file granularity. We can dedicate slaves to individual files. One of the cool things with big files is the way we manage them is we can address them in segments. So even if you just have one giant file for a large tablespace, RMAN and other parallel operations can still dive into that file in parallel chunks. We're not limited in our parallel operations. One thing I will mention though is if you are using big file tablespaces, generally I wouldn't be relying too much on the auto extend facility. And the reason I say that is with a normal tablespace, you might have say 12 files associated with it. If that tablespace needs to grow dramatically, you're doing a big data load, for example, file operations can be done in parallel. So what will happen is all 12 of those files can be grown at the same time. So if you need to grow that size by say 50 gigabytes all in one big hit, let me make it 48 gigabytes because I can divide by 12. If I need to grow that tablespace by 48 gigabytes, I can grow each of the 12 data files by 4 gig each, and I can do that in parallel. With a big file tablespace, I've only got one file. If I need to grow up by 50 gigs, that is done in serial. I need to incrementally grow 50 gigs on one file. So rapid growth in a big file tablespace, or in fact any tablespace that only has one file, is slower than if you had it spread across multiple files. So with big file tablespaces, as the name suggests, we're going to put big stuff in there. So look at pre-allocating, have lots of free space in there to avoid getting perhaps a slowdown when you have to auto extend. One of the cool things in all versions of Oracle from 11 onwards is you'll notice there's a background process called SMC0, Space Management Coordinator. It actually goes and tries to look at growth rates in your tablespaces, and rather than letting your tablespace get full and then auto-extending, it will actually try auto-extend in advance to avoid you getting stuck with a slowdown, especially for big file tablespaces. So that's big file tablespaces, a way of getting huge files and not as many files on your database. Okay, data patch. Data patch. When I patch a database, I run opatch against the Oracle home. That's the thing that patches and updates all the Oracle binary, the Oracle software distribution. And then we have to run data patch against all the existing databases that are in or attached to that particular Oracle home. Most of us know that it's always in the upgrade guide. But what about when I create a database after I've done opatch? So let's say I've got 11.201, I've patched it to 11.204, I've data patched all my existing databases as well. What do I do if I now create a brand new one? Because it'll be using the 11.204 software. Do I have to run data patch afterwards? And here is the nice way of describing it, and I'll simply say, it depends. Now, I'm going to set something running because it takes a little bit of a while to run. And we'll come back to it. So the answer is, it depends. I know that's a fairly vague answer and it'll probably cause some angst, but let's talk about why it depends. Don't get me wrong, our intention was always that you would never ever have to run data patch except if you were patching an existing database. That should just be a one-off operation. Take my database from version X to version X.1, data patch run as part of opatch, that's it. That was our intent, but we didn't quite get there. So here's what you need to be aware of. If you're on 12.1, after you create a new database with freshly patched binaries, you need to go run data patch afterwards. For every new database, you need to run data patch. For 12.102, it's also manually needed. Yes, for manually needed after you create a new database. For 12.201, it was a maybe. Depended a little bit on platform, and also there was a patch set update that came along for 12.201 to fix this. That is, create a database after you patch the software, and we're going to sort out data patch for you. So as long as you're a regular applier of patches and you're on 12.201 or above, this is now a non-issue. You never have to do this anymore. We will invisibly do data patch for you whenever you create a new database. I put data file copy down there because also around this time frame, you're probably familiar with when you use database configuration assistant, you can choose when you create a database whether to create it from scripts or create it from copying data files. The quicker way is copying an existing set of data files. Those data files obviously were never patched. So even on 12.201, if you were to create a database from those files as opposed to from scripts from source, then afterwards you would need to run data patch. So there's a little bit of sort of idiosyncrasies there around the 12.201 as we were getting this thing finally fixed. And finally, from that point onwards, we're all good. Data patch now has ceased to be something you need to run unless you are actually really running a patch. When in doubt, and that's why I set something running before, one of the cool things with data patch, here's data patch running on my 19.5 instance. Almost all of our scripts, and this is a compliment to the upgrade team inside Oracle, things like opatch, data patch, etc., are all nowadays auto upgrade, another one, are always rerunnable. And if you've had a failure, they'll normally pick up from where you failed. If they've run to completion, they are harmless to run again. So I've run data patch here on a system that I know is been happily data patched, and you can see it logs on. It ran at 9:36, it ran to 9:37. So this one took a minute and a half to run, which is why I started it early. And you can see, effectively, it went connected to the database, it went hunting, and it said, yep, you're on 19.5. I'm trying to data patch to 19.5. There is nothing that needs to be done. So the cool thing with data patch is, if you become fastidious and you say, I don't trust Oracle, I'm going to make sure I always run it just in case, then you'll be fine. You can run data patch as often as you want, and hopefully you'll gain our trust again in the sense that from 18 onwards, you never have to run data patch when creating new databases after you've patched your software distribution. So it's a nice thing we've cleaned up. It's pretty cool. Whew, drink of water. We might actually get through it. Oh, I've got something in the Q&A, which I never look at. I always look at the chat line. Okay, let me answer this. So what is the best use case for small file tablespaces and big file tablespaces? Okay, I'd be inclined, and I wouldn't take this as gospel. This is simply because I'm a lazy DBA. I like doing as little as possible and having the database look after as much as possible. For me, typically nowadays in these worlds of disk farms and SANs and striping, I would use big files across the board. You know, the days of wanting to add multiple files, generally I find is disappearing. Unless I've got some physical infrastructure problem that means I need to deal with things in small files, I would generally go big files across the board. Sorry, did I repeat the question? The question was, what is the best use case for small file versus big file table spaces? Which ones you'd use under which circumstances? For me, I pretty much go big files all the way, unless I know that I might be, for example, needing to move files around and I want to do it in a more granular fashion. But unless there's exceptional circumstances, it's big files for me. The other question was, so in 1819, we do not have to run data patch separately. That is correct. That is my understanding. Basically, when you create that new database, when you upgrade a database, then yes, you do run data patch across them all. But if you create a brand new database, data patch will be taken care of for you. Thanks, Sanjeev. I'm sorry I didn't see them earlier. Normally I look in the chat line with the Q&A, but thank you. Faster installations. Don't get me wrong. DBCA, the Database Configuration Assistant, is cool. I like having a GUI, but it also can be a little bit tedious. If you're like me, and often if someone says, oh, can you please test something on this version, or I want to try something, I don't want to run it on an existing database and cause damage. If I want to test things like backup and recovery or corruption, or as DBAs do, we want to test out our knowledge and our skill base regularly, then I'll create a new database. But it's a bit tedious. You go into that takes a while to start up, and then you're familiar with this, so it goes great. It says, yes, I'm initializing the JVM, etc. And you sort of stroll through that list of steps. Choose the database, choose whether it's container, choose this, choose that, choose where the storage is going to be. You continue on and ask lots and lots of questions. It doesn't take long, but it's something that that you're going to basically, with the exception of the database name, is you're going to type in the same information every single time. One way of speeding that up is at the final page, and this is something that I think is commonly done by DBAs, so it probably won't come as news to you, is we might do something like this. As well as creating the database, we want to save a set of scripts. So if I need to run this database again, create this database again, I can just run the scripts. Or we might choose to save it as a database template, which stores the information for that database, such that next time I can just load up a template and bypass some, but not all, of those screens we just saw. They're both good options. Don't get me wrong, I'm not dissing them. They're good options to pursue. My only concern is, even if you store it as scripts, the result you end up with is a folder full of scripts, and you need to run them. Now on Windows, you can see it creates you a bat file, which drives the whole thing. On Linux or Unix, it creates you a shell file. But still, we often have to go in there. If I'm going to create a different database now, I have to go hunting and find whereabouts in all those scripts the database name was. If I'm creating a database called ABC, and I've done that, my next database is called EFG, I have to go hunting for all the occurrences of ABC in that set of scripts if I'm going to try get some benefit of reusing. It's fiddly. One thing that some people aren't aware of is that DBCA, in fact, a lot of our configuration tools have a command line interface. And it's a pain to type in the first time, but once you've done it, it literally becomes a one-line operation to create a database, which, most DBAs, we're lovers of the command line. And this is how it runs. You can use DBCA -silent, means it won't bring up any of the in screens. Now this is all on one line. I've put it down the screen, but it actually goes all the way across one line. You can use your end of line separators depending on your environment, but it just goes on one line. And this is literally, we just type these in, and once you've got one of these, you're done. You don't have to, you simply save it in a file. You can choose to have a response file, but you don't need one. I don't need to, like in the old days of the universal installer, go through it and save a list of responses and then replay them. You don't need a response file. And all these parameters are documented in the universal installer guide and the configuration guide, but you can just take them off this slide if you want. I'll put them on my blog at some stage. I'm going to create a database. It has a global name. I give it an Oracle SID. I choose the character set. Hopefully everyone's using UTF-8 character sets across the board. I can choose an existing template name if I want. So if I've built a template in the past using DBCA, I can use that template. I can create it as a container base, yes or no, so true or false. If I'm doing a container, which of course we all are because that's the only thing that's supported in 20C onwards, I can do number of PDBs, give them the PDB names, give it some passwords. Hopefully you'll choose better passwords than I just did. Choose the memory settings. I go automatic memory management false, which is the default from 12.2 onwards. We don't use automatic memory management anymore. We use the shared pool automatic management and the PGA management, but we keep them separate. Choose a total memory. You can actually nominate SGA size and PGA size if you like. I'm using file systems in my storage. It could be ASM. That's where all my data files are going to go. Ignore the prerequisites, which means I'm just being lazy here. It's not going to go through and prompt me for those things that normally it might say, do you have enough swap space? Do you have this, etc.? It'll bypass all that. I'm not going to hook it up to EM. We're done. And literally, you hit return, and that's what happens. You just let it chug away. And it is literally going through the exact same DBCA steps. It's not bypassing anything. It's just using the exact form, but it's doing it at the command line level. And this will simply pop up. You can see the first thing it gave me was 2 warnings saying your system passwords are way too lax, but you get a nice progress and it grows, and then we're done. If you're on Windows, it does all the things you'd expect. It creates the services under the services tree, etc. It does everything that DBAC does, just at the command line. So this, I think, is a much, much simpler and faster way of creating the database, even faster than scripts, because scripts are hard to edit if you want to change the database name. With DBCA on the command line, it literally is just change some flags, create as many databases as you want. That's pretty cool. And the final thing, of course, is command line interface means it can be automated. So if you've got Docker scripts, if you've got Liquibase, if you've got various things like that, Vagrant, etc., that all sit in some sort of large set of automation tools, you can now put database creation in that as well, as opposed to having to, hey, everyone, stop the automation. I just need to create a database, and then we'll resume. Okay, 9:47. Oh dear. We might not finish, but we'll get through most of them. Instance caging. What do we mean by instance caging in the context of the Oracle database? Instance caging is very simple. It's about slicing up the pie. And what do I mean by the pie here? In my case, I'm talking about the most precious resource, the thing that you get charged on for Oracle, the CPU. It's very rare nowadays that we have a single database on a server. Servers are so ridiculously powerful that we generally have lots of databases on them. I know customers that consolidate literally thousands of servers that were 10, 15 years old onto a single Exadata machine. It's ridiculous what a high-powered server can do in terms of database volume nowadays. It's one of the motivations for pluggable databases. But let's assume we have a single server and it's got 2 databases on it. One's called sales. It's what drives our business. It's the retail operation. It is the single most important database in our organization. It controls whether we make a profit each year. Then we have another database called Social Club. Now, as the name suggests, it's where people put their fun activities they're going to do as employees, etc. It would be a bit of a disaster if someone ran a rogue query on the Social Club database that slowed down your sales database. But out of the box, that's how databases work. They all have an equal footing, an equal right to grab CPU attention from the server. So all it needs is some bad code, some bad design, some poor analysis in our Social Club database, and that could actually cause all sorts of problems for your sales database. What we want to do is be able to control what slice of the pie each of those databases get, such that our sales database is always guaranteed to have some level of control. So let's do it with a demo. I'm going to use my trusty PC as a server and see what we can do in terms of controlling the CPU allocation to a database. Now then, let's window. This machine has 6 cores and they're hyper-threaded, so the CPU count by default comes out at 12 on this machine. Now I'm going to smash this poor old machine. I'm going to literally start off a whole stack of routines that are just doing primary key lookups, just in an endless loop. In fact, when I hit return, you'll see a whole stack of windows appear. So some of them won't appear on your screen share, but you can get the idea that each one is just basically going around in an endless loop doing primary keys. I'm not sure how good the microphone is, but rest assured the fan on my machine has just gone ballistic. Now, if I bring up Task Manager and let that come onto screen, you can get a rough idea what my machine is doing at the moment. It is absolutely stressing. You can see it, we're pegged at 100%. If we look down here at utilization, we're at 97, 98%. Let's assume this is my social club database. I have just totally consumed the entire server with my bad programming here. The salespeople are going to be jumping up and down because they don't get a slice of the pie. I'm hurting the critical database on my system. Let's kill these off before too much damage gets done. And the fan on my machine returns to normal. So instance caging is how I can guard against this. I'm going to run a second demo here now, which is the exact same set of processes. But as an administrator, I want to make sure that my social club database cannot harm the machine. As we saw before, my CPU count is currently at 12, but what I can do with Oracle, what I can do with Oracle is change the CPU count just at the initialization level to 2. And as you can see, I can do it without having to bounce the database. I can dynamically change this to whatever I like. Now in this social club database, I've said you are capped at a CPU count of 2. Let's now crank up the same amount of work. Still just as many concurrent sessions, absolutely trying to smash my machine. Let's bring up the task manager again. Notice now, even though I'm trying to do the same amount of work, I'm only using about 50% CPU. It would actually be a little bit less. This, obviously, we're actually doing a recording here and recording some video as well. That's also contributing to the overall CPU. But you can see I've got a lot more headroom left over now, plenty of space left over for my critical sales database to get that slice of the pie. That is instance caging in a nutshell. We can actually divide up resources just using the CPU count parameter to make sure that particular instances on a machine don't chew up too much information, too much CPU pie. And the cool thing is, as we saw, it's dynamic. If I was to up the CPU count to the social club database, it would get a bit more. If I lower it, it would get a bit less. So you could have particular strategies like at nighttime, the data warehouse load database gets more. Kill off all these before my machine melts. There we go. So I can choose this dynamically. I might have my sales get top priority through the whole day, but overnight, when I got, for example, big batch loads going to my data warehouse, I might crank up the data warehousing stuff to get more CPU and lower the sales. I have that nice flexibility. So it's pretty cool. Is there any license impact? Question came in, is there any license impact for instance caging? Oops. Just lost my window. In terms of licensing for instance caging, there is not a license implication because those cores are already licensed. If you're running Oracle on a 12-core box, you're licensed for 12 cores. The only way that is not the case if you're running Oracle inside one of Oracle's VMs or one of the systems which we support in terms of hard partitioning. But in any of those cases, the underlying database gets a view of the outside world based on it. It just thinks that the partition is the entire machine. So to give you a scenario there, if I have 12 cores and I've hard partitioned that machine into 2 lots of 6, and inside one of those machines of 6 cores, I've got 2 databases, both of them will see as if I've got 6 CPUs. I might instance cage one of them down to 2 and the other one down to 4. It doesn't really matter because I always have to license all 6 cores anyway. Instance caging is a way of slicing up your existing license cores. Okay, let's move on. One thing I should state is instance caging only comes into effect if you have a resource manager plan set. So if your resource manager plan parameter is null, you'll see no impact from instance caging. You can set CPU count to whatever you want, it won't change anything. So resource manager plan must be set. If you don't have one, you can simply set it to default_plan, which is the one that comes out of the box, and that will guarantee that instance caging pops in and works. Okay, let me stop the share. It is 9:55. There are more things we could move on to. The cloning database one is very, very interesting, and hopefully you'll be excited by that next month. That's if we're all still here. But thank you very much for joining in. I want to pull this well before 10 o'clock my time, because there are more office hours for you to get into, and I know that a lot of you are probably stuck at home looking for content, looking for things to do. So it's a good time for me to stop and let you move on to the SQL office hours or the Apex office hours. Both of them are coming up shortly. And as I said, please reach out to us if you're looking for more content. We would love to help. We can lend our facilities here. We want to make sure that if you are stuck working from home, you're going to at least help do a bit of personal development for yourself in terms of your understanding of Oracle technology. Thanks everyone for joining us, and I'll see you all again in the next office hours. Bye for now.